Okay, so now that we know how the sine and cosine function looks like, the question is how do we graph variations of these functions? In other words, what if we throw some transformations? So let us talk about that, and then we're gonna do some examples. Okay. So instead of doing some simple examples first, I want to go and do the most general case, and then we're gonna come back and do something simple. But this way we save time. So let's talk about, I'm going to do one example, and then these ideas of amplitude, period, and phase shift, they will pop up naturally when we try to do the example, okay? And so we're going to define these words immediately. So let's begin with an example, and let's say that we want to sketch the following function. So I sketch the function y equals -2 times cosine of 3x plus 6 pi. All right, so let's say that we want to graph this, and actually, oh yeah, okay, let's leave it like that. All right, so y equals -2 times cosine of 3x plus 6 pi. So if we want to graph this function, the way that we're going to approach this is the same way as we approach graphing functions, back in college algebra, using transformations. So the question is, can we identify what transformations are we doing? It's kind of clear that we're using the parent function that we are working with is the cosine function, right? Because we see cosine right here. So the question is, are there any transformations happening to this function? And for example, this can be seen very easily by doing the following. So the first thing that you should do is make sure that you factor out any coefficient that you have in front of the x. So here, I'm going to go ahead and factor out a 3 in front of the x, and then this will be x plus 2 pi. Okay? All right. So whenever we say it like this, we can immediately spot several transformations that are happening. So first of all, the -2 is going to have two effects on the graph of cosine. So the times 2 means that we're going to be doing a vertical stretch by a factor of 2, right? So this is going to affect the range of the cosine. Instead of being from 1 to -1, now it's going to be wider. It's going to be between 2 and -2. The negative is going to flip our picture, right? So that's what multiplying by -1 does. The picture is going to be flipped. And then what's happening inside the argument? So we have a times 3. So what this does is a horizontal compression by a factor of 3. So remember, when you multiply the x by a number bigger than 1, you compress the graph horizontally. If you multiply by a number less than 1, you stretch the graph horizontally. And then the +2 is a horizontal shift to the left by 2 pi. Now, as you can see, I told you a lot of transformations, and I actually told you how many? 4 different transformations. So if you're going to graph these using transformations, you can do it college algebra style, because you already know the basic graph of cosine, but it's going to take you some time, okay? So the upshot here that we want is to actually graph this in one shot, okay? So what we would like to do is be able to have our x and y, and then somehow, produce the graph of the function without having to do any transformation whatsoever. So this is what I'm about to explain right now. But there will be some names that are going to pop up, which are amplitude, period, and phase shift. Period, we already know what it is, but the amplitude and the phase shift, these are just fancy words for amplitude. Has to do with this vertical stretch that's going to be happening to the function, and phase shift have to do with this horizontal transformation that we're going to be doing. Okay, so phase shift is a fancy word for a horizontal shift, and amplitude is a fancy word for vertical compression or stretch. Okay, all right, so we're going to take a look at this pretty quick. So the first thing is to identify what's the period of our function. Okay, so first let us try to figure out the period. And why is this important? Because once we know once we know the period, then we just focus on the location of the main cycle We're gonna graph that, and then we just keep on repeating the same shape over and over again. Because all of these functions, they are periodic. Remember, cosine is periodic. Regardless of what's happening inside in the argument, it's going to eventually repeat itself, okay? So we're gonna come up with a formula to figure out the period, okay? But my advice to you is the following: reason through it. So, and how do we do this? We are doing cosine of something, and we know that for the cosine function, whatever we have inside, it always has to be between 0 and 2 pi if you want to figure out the main cycle. So the main cycle will have this quantity, and so has this quantity between 0 and 2 pi. Okay, because remember, the basic function is cosine of x, and the main cycle is when x is between 0 and 2 pi. Now we're just changing x by whatever is happening inside that argument. So let's use that information to figure out the location of the main cycle. All right, so main cycle. And what I'm referring to the main cycle is that, as you know, there are transformations happening. Let me show you the cosine function again. I want to see this red cycle that we have here in the picture. Where is it going? Okay, so we know that we are moving it to the left by 2 pi, and we are also doing some sort of compression horizontally. Okay, so after we do those shifts, where those transformations, where will that red cycle end up with on the x-axis? This is what I'm trying to figure out right now. And we can do that pretty simple. You just have to solve a couple of inequalities. So the main cycle says that the stuff that is inside the cosine, it has to be between 0 and 2 pi, so that's what I'm going to write. So what do we have inside the cosine? We have 3x plus 6 pi. I'm using the original version, and we want this to be between 0 and 2 pi. So let us figure out where is x. So I'm going to solve for x. So in this case, we're going to do it in one shot by working on the three sides, okay? So we subtract 6 pi everywhere, just solving for x. So we get negative 6 pi less than or equal than 3x less than or equal than negative 4 pi, and then we divide everything by 3. So we get that x is going to be between negative 2 pi and negative 4 pi over 3. Okay, so this right here is the location of the main cycle. That cycle that was between 0 and 2 pi originally for the cosine function, after all of these transformations are done, is going to be in this location on the x-axis. So this right here is the location of the main cycle. Okay, so what I recommend you to do is the following. After you figure out the location, then we're going to draw here a picture of the main cycle. So I'm not drawing my x and y yet, but I'm going to draw my main cycle. I know that it begins at negative 2 pi, and now we're going to see why that makes sense. And then it's going to finish at negative 4 pi over 3. So remember that after we do all of those stretches, so we need to do a horizontal compression, then that plus pi over 2 means that you need to go to the left 2 pi units. And if you think about it, let me refer you back to the cosine function. This point, the point 0, 1, this point right here actually is not affected by the horizontal compression that we are doing. Okay, when you compress by a factor of 3 this picture, that point will still stay there because the x value is equal to 0, so that's not affected. What's going to affect the location of this point is when you shift it to the left by 2 pi, and then that point is going to go, instead of being at 0, it's going to go to 2 pi. And that's the left endpoint of our main cycle. And that's what we just figured out without inequality. Okay? Now, of course, why is it that the right endpoint is not the one that we have here in this picture shifted? Well, because remember, there was a compression. So before you move, you do the compression, this point is going to get affected and will go somewhere. And then when you shift it, it will end up in the negative 4 pi over 3 that we figured out. Okay? So that's what's happening. And you will see that the whole point is that we can actually figure all of this out very simple without having to worry about transformation. But right now, I'm bringing back transformations all the time so you see the meaning of what we're doing and why this works. Okay? All right, so we found the location of the main cycle, which is from negative 2 pi to negative 4 pi over 3. So I claim that we can use this to figure out the period. Remember, period is just the length of the cycle, because cycle means this is exactly the shape that the function has until it starts repeating itself over and over again. In other words, the length of that cycle will tell you the period. So right here, this length right here tells me the period. So the period equals the length of any of the cycles, okay? So the length of the cycle. So how can we find the length of the cycle in this case? When you have an interval, how do you find the length of an interval? You do right endpoint minus the left endpoint. So this is going to be negative 4 pi over 3 minus negative 2 pi. Do you understand this? Are you following this logic so far? Okay, so then what would be the period? The period would be negative 4 pi over 3 plus 2 pi. And to add these, what we do, multiply top and bottom by 3. So we get 6 pi minus 4 pi, that's 2 pi. So we get 2 pi over 3. That's our period. Okay, so we get 2 pi over 3. And remember, this is just the length of the cycle. Let me use the word period. All right, so the period of this function is 2 pi over 3. So that means that every 2 pi over 3, we are going to be repeating the same shape. Okay, that's what this is telling me. So now what we should do is, as you know, the cosine function always has 4 key points, or I should say 5 key points. Okay, let me go back. And remember, everything we're saying about cosine also applies to sine. Okay, and adjusting that in the relevant way, of course. So this cosine function, the main cycle has 5 key points, and they are exactly the ones that you see here, right? So the point at 0, 1, this guy, this one down here, the point at 3 pi over 2, and the point at 2 pi, at 2 pi, 1. So those 5 points, they will always show up no matter what. It's just that they are going to be in different locations, okay? But those 5 points, you will always sketch them before you draw your cosine function. So your key points will always look like this. One on top, one in the middle, another one down, and back to the middle, and then to the top. So that then when you join the dots, you get your shape. And then you keep on repeating the same points. One on top, one middle, one down, middle, up. And then you keep on doing the same thing over and over again. And same thing here. Middle, down, and middle, top. And you keep on doing this to the left, and so on and so forth. Okay? So we are going to be always doing that. And the key here is in figuring out the location of these key points. Once you have these key points, then that's it. You can graph your function. Okay, so this is what we are after right now. Where are these 5 points? And they are, of course, they are, as you can see, they are equidistant from each other. In other words, in the main case, they are apart by pi over 2, because that's what each of the quadrants represents. So you take the main cycle, divide it into 4 equal pieces, and each of those pieces represents the location, the x location for each of these key points. So what do we do here? We have our main cycle. Now our job is to split this into 4 equal pieces. So we do half here and then half again. And then these 3 more points that we find out are the location of the 3 missing main points, because we already know that the first point is going to be somewhere here above negative 2 pi, and the last point is going to be somewhere here above negative 4 pi over 3, or maybe below, because remember that we are flipping. They will actually be below because we're flipping the picture. But let us not think about the flipping now. And then we know that this will be the middle, this will be the bottom point, this will be the middle, then back to the top, so that then you have your picture. And then of course it will be flipped, okay? It will be flipped. So this is the reason why we're doing this now. Okay, so let's try to figure this out. What are these points? And the key is in what I just said. These are equal pieces, so they are all equidistant from each other. So what's the length of each little piece? They are all the same. Let's call it L. And how do you calculate this? Well, this length is just the length of the main cycle divided by 4, right? We took this big piece, this cycle, and we divided by 4 equal pieces. So the length is whatever the length of the cycle is divided by 4. Length of cycle divided by 4, because we have 4 pieces. But remember that the length of the cycle is just period, right? So that's just the period. So how do you figure this out? You take your period and you divide it by 4, which in this case is 2 pi over 3 divided by 4. So the 2, let's see, the 2 cancel with the 4, so you get pi over 6, okay? So we're gonna be moving in increments of pi over 6, all right? So with this information, we can now figure out the remaining 3 points. So it's easier to have a denominator of 6, so we can start moving. So negative 2 pi is the same thing as saying negative 12 pi over 6. So then an extra pi over 6, that would be negative 11 pi over 6. An extra pi over 6, that would be negative 10 pi over 6. That simplifies as negative 5 pi over 3. And then the next one would be negative 9 pi over 6, which simplifies as negative 3 pi over 2. And just to check, if you add an extra pi over 6, you will get negative 8 pi over 6, which simplifies to negative 4 pi over 3, and you know that that's your right endpoint, and then we're good to go. Okay? So, moral of the story, you can actually, from this picture that you see here, from this main cycle, all you need to worry about is this guy, because once you know this guy, the rest of the numbers you can figure out easily if you know the period. If you know that the period is 2 pi over 3, how can you figure out the endpoint? Just take the left endpoint and add the period to it, because that's the length of the cycle, and you get the other endpoint. So negative 2 pi plus 2 pi over 3 will give you negative 4 pi over 3. And to get the in-between guys, all you have to do is find the length of each little piece, which in this case is period divided by 4, and you just keep on adding this number until you find the points that you need. Okay, do you understand how we constructed this main cycle? Because now we are ready to graph with this information. The whole point is getting this picture that we have right now of the main cycle. Do you understand this? Okay, so again, once you, it's really not tricky. Once you start doing examples, I know because I'm telling you a lot of stuff. It's just that I'm telling you things so that hopefully it makes sense what we're doing. Then you just, you don't have to worry about all the stuff that I'm saying, and you just go straight to constructing the cycle, which is really simple. Okay. All right. So then, yeah. So right now, just think of pi as being, I don't know, like, it's a constant, but think of it as being, like a variable or something, like negative 2 times a. And then, we just keep on working with these all the time, okay? All right, so let's go ahead and let's try to graph the function. So to graph the function, here is what we do. Now that we know the location of the main cycle, so I'm gonna put here my x and y. So let's look for the location of the main cycle, and we know that that's going to happen. It's going to be a negative 2 pi, and we go all the way up to negative 4 pi over 3. So every time that we draw, we usually should show at least 2 or 3 cycles, okay? So let's see, I'm going to declare, let's declare that 2 pi is this piece. So that means that we're going to go 2 pi this way, and then another 2 pi this way. Actually, should make it bigger. Let's say that by 2 pi we mean this big part. So negative 2 pi is going to be here. Okay, so then we want to go all the way up to negative 4 pi over 3. So negative 2 pi, then negative 4 pi over 3, that's a little bit more than negative pi. So let's say negative pi was here, then negative 4 pi over 3. If we keep on adding pi over 6, right? So remember, negative 4 pi over 3 is the same thing as, what is it, negative 8 pi over 6. Then you get negative 7 pi over 6. And then you're going to get negative 6 pi over 6, which is negative pi. Okay. I'm going to make this bigger. Otherwise, the picture will be too uncomfortable. Negative pi. So we have here one piece, and then here we're going to have another piece. This would be negative 4 pi over 3. Because this one right here, the one in between, is negative 7 pi over 3. Over 6. These numbers. Let me erase this. And rather, let me do this. 1, 2, 3, then 4. So this is going to be our negative 4 pi over 3. Then we're going to do one more time. So an extra one, this is going to be negative 7 pi over 6. And then here we're going to have negative pi. Okay. So let's see. Let's worry about our main cycle, which is from negative 2 pi all the way up to negative 4 pi over 3. Let me put it more here. It's just that my scale is just horrible. I don't like it. All right, here. Okay, so now remember, now we're going to use information, of course, of the negative 2. So normally you would write a graph that goes from 1 to negative 1, okay? But because we're multiplying by 2, we can easily see. So by the way, all of these that we did have to do with this part, okay? We did not take into consideration whatsoever what had to do with the negative 2. But we know exactly what that does. The multiplication by 2 stretches the graph between 2 and negative 2. And then the negative, what it does is it flips the cosine, okay? So when we're going to put our point, instead of going up, we're going to go down, okay? But that's the only difference. So that means that instead of being from 1 to negative 1, we're going to go to 2, between 2 and negative 2. Okay. So our picture is going to be between these two numbers, and again, the negative 2, the 2 in front is responsible for that. Now, what the negative does, it flips the graph. So here is what we do. Normally, the position of the key points would be, because now we know the main cycle, the position of the key points would be up, middle, down, middle, up. Now we need to switch this because of the negative. So it's going to be down, middle, up, middle, and down. Okay, so I'm gonna go ahead and get rid of the old ones because we don't need those. Okay, so it's gonna be negative 2 and negative 2 pi. Remember the values, which is negative 11 pi over 6. That's what we have here. Then it's gonna be equal to 2 at negative 5 pi over 3. then it's going to be 0 again, and negative 3 pi over 2. And then it will be down to negative 2 and negative 4 pi over 3. So now with this, we can draw the main cycle. So the main cycle will look, what is this? Something like this. Okay? So that's how the main cycle will look like. But now remember, we should draw several cycles. So let's draw a couple of more cycles so that we can figure out what's going on. So now we keep on going to the right, but now once we have the main cycle, all we have to do is repeat the picture. Let us just make sure that we have 4 more intervals. So that's why I was writing the extra numbers. So negative 7 pi over 6, negative pi. Now we keep increasing by pi over 6. So remember, negative 6 pi over 6, that's negative pi. So then negative 5 pi over 6. And then another one would be negative 4 pi over 6, which would be negative 2 pi over 3. And now let's put our key points. So down, middle, up, middle, down. And then we continue in this fashion. Okay? And then it's kind of clear that now if we keep on doing this, right, then we're gonna finish the graph. In other words, this keeps on happening this way to the right, and it's gonna keep on happening also this way to the left. But at least we draw the main cycle, so we can see here the period, right? So the period is this distance right here. That's the period in this picture. That's the length of each of the cycles that we have. So length of a full cycle. Length of a full cycle. And then notice that how wide the picture is, this is called the amplitude of the graph. So this distance right here, notice that this distance is 2, which also coincides with this distance right here. This is called the amplitude. This value is 2. We call this the amplitude of the graph. And this, of course, is given by the number that we have in front, which in this case, we have a negative 2. The amplitude is how wide it will open. So you take the absolute value of that number. That's what the amplitude is, okay? Because the minus, what it does is it flips the picture, but it does not affect the amplitude. And there is also something else that's important to see here, and is this line. We give it a name. This is called the midline of the graph, because notice that in this case, as the x-axis is cutting the picture by a half. So this is a special line for which from this point, from this line to the highest point of the graph, the distance is the same as that line to the lowest point of the graph, okay? So this distance is what we use to define the amplitude of the function. The distance from this line, this is called the midline, okay? So the midline is the line y equals to 0. Of course, it's the x-axis because we did not do any vertical shift. But if you pull this function up or down, then of course the midline is going to change, right? Accordingly, depending on whether you move up or down. Okay, do you have any questions about what we just did? I'm about to summarize all of this, and then we're going to do more examples. But did you understand how we obtain this picture? Yes or no? Okay, so let's see. Remember, the first thing that we did was we tried to figure out where the main cycle was, okay? And to do that, you just take the argument and you write it between 0 and 2 pi and so for x, okay? We did that, and then we got x is between negative 2 pi and negative 4 pi over 3. So that means that the main cycle is going to be where you see the red picture, okay? So it's going to be shifted. Instead of being between 0 and 2 pi, it was shifted to the position that you're seeing it. And notice that also is being caused to be, horizontally compressed. It's actually shorter than what it should have been for the regular cosine. And that's because the period happens to be 2 pi over 3 rather than 2 pi. And here is another hint. You see how we have a division by 3? We have 2 pi over 3. Notice that 2 pi is the period of the regular cosine, and we have a 3 right here, which was the number in front of x. This will actually be the case all the time. The period, you can always figure it out by calculating 2 pi divided by that number. I will write all of those formulas later on. Okay, now once we know the location of this cycle, that's it. Then you just graph. But to graph, we need to have some key points. And that's what we're trying to do next. Okay, so what are the key points? We have the main cycle, which is between negative 2 pi and negative 4 pi over 3. And then we know that we need to divide this into 4 pieces, 4 equal pieces, because each of those will tell you the location of the key point to graph your picture. And so all you have to do is figure out what the remaining pieces are. And since you're dividing this into 4 equal pieces, you take the full length, which is the period, 2 pi over 3. You understand how to do this one, right? It's just a difference of the endpoints of the interval. And then you take that number and divide it by 4. That's going to give you the length of each little piece. So this turns out to be pi over 6. So that means we're going to be moving every pi over 6. Okay? So start at negative 2 pi. Add pi over 6, you get negative 11 pi over 6. Another pi over 6, you get negative 5 pi over 3, and so on, until you find the remaining 3 points that we have here in red. Do you understand how we got these numbers? Okay, then we went to the picture, and that's what we did. We put the numbers in there. It's just that, you know, it took some time because now the scale becomes strange. Because we have all of these pi's, and then you know, the numbers are too big when you write them, but then the intervals are small, so it becomes messy. Anyways, once you kind of feel comfortable writing the numbers, you write them down. So I wrote the main cycle from negative 2 pi to negative 4 pi over 3. We'll worry about the other stuff later. And then we draw. The reason why we started down at negative 2 pi comma negative 2 is because of the flipping, remember. If we had a positive 2 instead of a negative 2, we will start above instead of below the midline, okay? So once you decide where to start, then the rest is automatic. You do down, in this case, middle, up, middle, down. So down, middle, up, middle, down. This is gonna give you this shape, okay? If it would have been the other way, if you didn't have a negative 2 and was a positive 2, you would start up, the middle, down, middle, up, and then you get this shape for the main cycle. Do you see this? All right, and then this allows you to draw the main cycle. All I did then is just draw an extra cycle. We usually like to draw several cycles, at least 2, okay? And so what do? Then you repeat the same thing that we did for 4 more intervals, but now we have all the information. You just need to keep on adding pi over 6. So from here to here, what I did was I added pi over 6, then pi over 6, plus pi over 6, and plus pi over 6. That's what I did to come up with the next 4 numbers. And then you draw again, you know, your 5 key points, or 4 more because you already have 1, which is the one that you finish with your cycle, and then you keep on drawing the same thing. And then, you know, this keeps on happening, etc., etc. For example, let's do one more. Since the period is 2 pi over 3, it's kind of, we should probably not stop here. Let's do one more, because now the distance from 0 is again 2 pi over 3. So that means that the remaining 4 pieces here are exactly the ones that we need. So there's going to be down, then middle, then up, middle, and down. So the picture is going to continue this way. Right? The same shape. It will continue like this, and then, well, now you keep going this way. Okay? So this is how this function looks like. So this is what we did. Now we're gonna practice this again one more time, but let me make one full remark. So I already told you what amplitude is. Amplitude is the distance between the midline and the highest point of the graph. and also the distance between midline and lowest point of the graph is the same, okay? And midline is clearly the one that cuts the graph in half. So it's, if you calculate the total distance between highest and lowest point, which in this case is 4, the midline is going to be at the level of half of it, which is 2. So the midpoint between 2 and -2 is 0, so I will give you the midline, okay? If you have a picture like this, and let's say that this is 8, and let's say that this is 3, for some reason, then the midline will be in between, which is, what's the distance? 5/2, so 5/2. So somewhere in here, we're going to have the midline, which is y equals 5/2. Okay, actually, not 5/2, but 8 minus 5/2. Okay, so what is this? 2.5. So 8 minus 2.5, that's going to be 5.5, right? So 5.5 is a midpoint between 8 and 3. So that's how we're going to figure this out. Are you okay with this? With this location? And then the amplitude is this one, right? The amplitude is this distance right here, which is going to be, what is it? 2.5. 2.5 and 2.5. Okay, that's what this amplitude tells you. The distance between the midline and the highest point, or the midline and the lowest point, is because it's the same. That's why we call it the midline. All right, so the last thing that I haven't written anything about is the phase shift. But like we said out loud, the phase shift has to do with this translation that we did. In this case, we move our main cycle to the left pi/2 units. So we will say here that the phase shift is -2 pi. So let me write this. So remark, the above graph. Notice that the above graph is actually the same. As if you have graphed the function -2 times cosine of 3x, but then you shift it to the left by 2 units. Okay, but shift it to the left by 2 pi units. This is called the phase shift. This horizontal shift, we call it phase shift. So this is called phase shift. That's the definition. I wanted that to be in red. Okay. This is called phase shift, and in this case, it is equal to -2 pi. So this time, we're gonna actually, when you talk about the phase shift, we talk about the number with sign. If you see a negative, that means that we're going left. If you see a positive, that means that we're going right. And it's gonna be clear in a second. So what is it that we want? What's the goal? As we did with this example, the goal is to graph the following function. So to sketch functions of the form y equals a times sine of bx minus c plus d, and similarly, like we did above, a times cosine of bx minus c plus d. Okay, so we're gonna use the above example to come up with some formulas, and then we're gonna use this in application. So we're gonna start doing some examples of functions and then graph it like we did above. Okay, but we're gonna use the work above to come up with some formulas. Okay, so again, for sine and cosine, it's actually the same thing. So I'm gonna be talking, whenever I talk about period, phase shift, amplitude, and midline, is the same thing for sine and cosine. Okay, so here the goal is to sketch this type of functions where a, b, c, and d are constants. Okay, these are real numbers. And the only condition that I will impose is that I want b to be positive. And I want you to understand that this is not really a restriction. If you have a negative b, Imagine that you have y equals 3 sine of negative 2x plus pi minus, I don't know, minus 5, something like this. And you wanted to graph this function, that's not really a problem. The fact that you have a negative is not a problem. We can always get rid of it by using the symmetry. You can factor out this negative. So that would be negative pi, and then minus 5 outside. And then we can use the symmetry of the function. Since the sign is odd, what happens? Because it's odd, this minus, we can take it out. Remember, that's what it means to be odd. So this is really the same thing as negative 3 times sine of 2x minus pi minus 5. And so if we wanted to graph this function, we first need to do this transformation, and then we're gonna look at this formula instead. Because the stuff that I'm gonna tell you, they deal with positive b only. They assume that b is positive, okay? And in the case of cosine, you can do the same thing, but in that case, the minus will disappear because cosine is even. But the point is that you can always write this function so that b is positive. So that's why this is not really, you know, a strong restriction, if you will. Okay, so let's go ahead and let's figure out the formulas that I'm talking about, and then we're gonna do examples. All right, so the first thing that we want to do is that we want to figure out what's the amplitude, the period, and the midline and phase shift from this general form. So towards some formulas. So what do we want? Formulas for amplitude, which we know what that means, right? That's the distance between the midline and the highest point of the graph, and also the lowest. Okay, so we want to figure out a formula for the amplitude, the midline, the period, and phase shift. And once we have all of this, then we are ready to sketch the function. Okay, so how do we find the amplitude? And again, for this, you can either look at the sine function or the cosine function is going to be exactly the same. So how do we find the amplitude? As you know, the number that has to do with the amplitude is whatever we're multiplying the sine or the cosine function by. In other words, A is the one that is responsible for the amplitude. Remember, in our example, we were multiplying by -2, and the amplitude was +2, because it's just a distance between the midline and the highest or lowest point, okay? So the amplitude is going to be the absolute value of that number that you see there. Amplitude is just absolute value of A, and it will tell you how wide your graph is going to be. Do you understand this? Okay, so next, something else that we can identify actually very easily is the equation of the midline. So what do you think would be the equation of the midline? Think about the graph of sine and the graph of cosine. Originally, the midline is at the x-axis, right? That's the line that cuts the graph in the middle, because you go up 1 unit and down 1 unit. So that's like the midline of the picture. Now, what would change in general? What do you think would make this line to change and become a different number? If we look at this general formula, what is responsible here for the shift, the vertical shift of the function? So this line changes if we decide to move this function up or down, right? If you take this picture up or down, then this line, this midline, will change. And what's responsible for this? What is responsible for this in the general form that we have written above? What makes the graph of the function to go up or down, or vertical shift? The plus d. Very good. This number right here is the one that tells you whether you go up or you go down. In other words, if d is a positive number, this means that we're going to go up that many units. So everything will move up in a symmetric way. So the midline will go from y equals 0 to y equals d. And if d is negative, the same thing will happen, it's just that it will go down instead of going up. But the midline will move along to whatever d is. So the equation of the midline is pretty simple. It's just y equals d, where d is that number. For example, in our case, our d is 0 because there is no d, right? So you can think of this as being plus 0. And that's the reason why the midline remains at the x-axis and is the line y equals 0. Okay? So notice that once you know the midline and the amplitude, then you immediately know what's the highest and the lowest point. So when you draw your key points, you know how high and how low you need to go. Okay? All right, next, we need to figure out a formula for the period. Okay? And to do this, we're gonna do this very simple. Like I said, we just take the term that is in the argument of the function. In this case, is bx minus c, and then we solve the inequality between 0 and 2 pi. So that's what I'm gonna do. I'm just gonna do this one time because then the rest is always the same, right? We're doing this in general. So let's solve for x. So solving for x, what do we get? I'm gonna add c everywhere. So we get bx is between c and 2 pi plus c. And then I'm going to divide by b. So I divide by b. And so we're going to get that x is between c over b. And so I'm going to write this as 2 pi over b plus c over b. Okay? So we get this information. And notice that we can divide by b here because b is positive in particular, is different than 0. Now, if we want to figure out the period, so this tells me then that if we want to figure out the period, remember, all you have to do is divide the endpoints because this is where the main cycle is going. Okay, so you subtract the endpoints of this interval. So the period is going to be 2 pi over b plus c over b minus the left endpoint, which is c over b, and then it's clear that the c over b is gone, and we get the period is given by 2 pi over b. Okay, so this is always the case. In other words, this plus or minus c, this minus c that we have here has no effect on the period whatsoever. The guy that's responsible for the period of the function is the number that is multiplying the x, and it will always be 2 pi divided by that number. Okay, so number 3, we have a formula for the period. In this case, the period is always 2 pi over b, where b is the coefficient in front of x. In our example, that coefficient was the number 3, right? We have 3 multiplying x, and we figured out that the period was 2 pi over 3. Remember, this would tell you how long the cycle is. So you will know where to, once you know the starting point, you know exactly where to finish. Just add 2 pi over 3, and you will get the ending point of that cycle. Okay, do you understand how we found the period? Now you don't have to do this every single time. You just have to remember the formula. But then, of course, if you forget the formula, this is what you do. Just take the stuff inside your sine and cosine and write it between 0 and 2 pi, and then solve the inequality. But it's easier to just remember the formula. But it's up to you. Questions on the formula for the period? Okay, and then finally, we want to figure out what's the phase shift. So phase shift, in this case, we need to say, this is a way of saying how much did the graph move horizontally? Did it move at all? And actually, we can see that it did, right? So originally, our main cycle was between 0 and 2 pi. So the left endpoint of the cycle was at 0. And we can see here that now our x, the left endpoint of the x in the main cycle is c over b. So this means that the picture moved C over B units horizontally. Now, how do we know whether it moved right or left? Well, the sign of C will tell you how it moved. Because remember, we have a minus here, right? So if C is positive, what does that mean? It means that the graph is going to move to the right that many units, C over B, because you need to factor out the B. And if C is negative, that minus will turn into a plus, and then remember that that meant that we're going left instead of going right when we think about transformations in the college algebra sense. So the phase shift is going to be given by the ratio C divided by B, okay? And then whether it goes right or left is given by the sign of C. If the number C is positive, then we're gonna shift right that many units. And if the number C is negative, then we're gonna shift left that many units. So in the example that we did, notice that C is actually negative 6 pi, because if you were to write this in the standard form that we have been talking about, this is negative 2 cosine. 3 is positive, but remember, we need to have a minus, so you can write this as minus 6 pi. This now has the form that we're discussing, so this guy right here would be C, and then this guy right here is B. So the phase shift is C over B, which would be negative 2 pi. And what that tells you is that we are moving to the left 2 pi units. Okay, and also notice that once you know the phase shift, this is exactly where you begin your main cycle. So with this little formula C over B, you will know where to begin the main cycle. So when you're drawing your picture, you know that you're going to start here at C over B, whatever that is, and then you know the period, which is 2 pi over B, so you add it, so you get your right endpoint. So this will be C over B plus period. And then to find the 4 key points, you know how to do it, the remaining key points. Split into 4 equal pieces, and the length here is period divided by 4. The length, and you just keep on adding that number until you reach the right endpoint, and then you start graphing. So this is a summary of what we discussed above. All right, so again, I just gave you a bunch of formulas, and what I did was try to justify why these formulas were the way they are. Now let's use them, okay? So I'm gonna give you a function, and then we're gonna find the amplitude, the phase shift, the midline, period, and then we will use this information to graph the function, okay? All right, let's see. So example. So find, let's see, find the amplitude. Find the amplitude, phase shift, midline, and period, midline, period, and then sketch. And then see part A, we already did a cosine function, so I guess let us do now a sine function. So let us do y equals 2 times sine of 4x plus 3 pi plus 1. Okay, so here we have a function. Let us actually try to figure out all of this information that we need. Okay, so for this, we should figure out what are A, B, and C. And for that, the first thing that we need to do is write it in standard form. And remember, a standard form means the coefficient in front of x has to be positive. Okay, it is positive. And we want to see a minus instead of a plus in that argument. Okay, so we need to rewrite this. You don't have to, but then you kind of need to do it in your mind. So it's better to just rewrite it. So if you see a plus in there, then you just write it as minus minus. Because this will allow you to immediately identify your A, your B, and your C. All right, let's see and D. What's A, B, C, and D? So what's the value of a for this function? So what I'm asking is, thinking about this general form that we have up here, okay? This general form. So the value of a is 2. What's the value of b? So b is 4. What's the value of c? Negative 3 pi. Good. And what's the value of d? So Ramses, remember, c is the whole thing, okay? So it will be negative 3 pi, and the value of d is 1. Okay, good. So now let us answer the questions. What do we want? We want amplitude. So amplitude, midline, period, and phase shift. And well, we have, we have the formula for all of this. So how do we find the amplitude? The amplitude is given by the absolute value of a, which in this case happens to be 2. So the amplitude of the function is 2. So what's the midline? We know that the equation is y equals d, right? So the midline is y equals 1. All right? So how about the period? What's the period? The period is, remember, 2 pi divided by b. So in this case, the period is going to be 2 pi over 4 or pi over 2. Questions on finding the period. So it means the length of our main cycle is going to be pi over 2. That's what this means. Okay? The length of our main cycle is going to be pi over 2. You okay with this? All right. And then what's the phase shift? The phase shift is given by c divided by b, which in this case is negative 3 pi over 4. So this is the phase shift. So what is the phase shift telling us? Remember, the information here is the horizontal shift. So what that means is that we're going to be going left 3 pi over 4 units. That's information encoded in this phase shift, okay? That whatever, when you think of the sine function, this is going to be shifted to the left 3 pi over 4 units. Okay, so questions on how to find these 4 quantities: amplitude, midline, period, and phase shift. Questions?
So C has to be negative?
And so in this case, C was negative, but it doesn't have to be. It just would have been a minus. Imagine that the original problem would have had a minus instead of a plus. Then what would be C?
3 pi?
It will be positive 3 pi. So, it depends on the problem. It doesn't have to be negative. It depends on the problem. It's just that to have it in a standard form, we want to have a negative here so that we can correctly identify C.
Oh, okay, I got it.
That's the point. So that's the reason why we had a plus, so we wrote it as minus minus. But if we originally had a minus, then it's already in standard form. Because, these formulas that I gave you here, they assume that you have a function that looks like these ones that we did here. And we see a minus C. So that's why if you want those formulas to work, you have to make sure that you write it in this form, where B is positive and there is a minus in there instead of a plus. Is that okay?
Yeah, thank you. I got it now.
All right, good. Okay, so now that we know how to find these quantities, again, these are just formulas, right? Just use formulas and then you get these quantities. How do we use these to graph? So let us actually graph the function. So remember, I strongly encourage you to first figure out the main cycle. So now we sketch. And to sketch, instead of worrying about all of those transformations, let's first do the main cycle. So main cycle first. And remember, the information on the main cycle is encoded right here. The phase shift tells me that is negative 3 pi over 4. So you immediately know that the left endpoint is negative 3 pi over 4. The number that you write there is whatever the phase shift was. Remember what we have here in general. This is the picture of the main cycle. To the left, we have C over B, which is phase shift. Okay, so now that we know that this is the left endpoint of the main cycle, what's the right endpoint? So what do we write in the right endpoint? So right here, well, the length of this is pi over 2, right? So all of this has a length of pi over 2. That's a period. So the length here is period. This is what it means to have a period, which is pi over 2. So to figure out the right endpoint, you just need to add pi over 2. So what's negative 3 pi over 2 plus pi over 2? Negative 3 pi over 4 plus pi over 2. What is that? Anybody? So this guy is going to be negative 3 pi over 4 plus pi over 2. What is that number? What's negative 3 pi over 4 plus pi over 2? Remember, you want to have the denominators the same. Multiply top and bottom by 2. So you're going to get negative pi over 4, right? So negative pi over 4. And we get that by just doing negative 3 pi over 4 plus pi over 2. Okay, so once you know where to begin and where to finish, then the other points, remember we split into 4 equal pieces, and the length of each piece is going to always be period divided by 4. So that's pi over 4, right? That's period divided by 4, which is pi over 8. So that means that to figure out what are the next points that we have, we just keep on adding pi over 8, okay? To do this quicker, my advice to you is write everything in terms of, denominator 8. So this left endpoint that we have is the same thing as saying multiply top and bottom by 2, so negative 6 pi over 8. So now you can figure out the numbers quicker. So if you add pi over 8, you will get negative 5 pi over 8. You add pi over 8, you get negative 4 pi over 8, then negative 3 pi over 8. And notice that if you add another one, you will get negative 2 pi over 8. That cancels to negative pi over 4. And this negative 4 pi over 8, we can actually simplify better and write it as negative pi over 2. Okay? So instead of negative 4 pi over 8, I'm going to go ahead and write negative pi over 2. But it's good to think about, denominator 8, because then it's easier to add and come up with the other points. Are you okay with what we have so far? Okay, so the moment that we have this, then it's time to graph. So now we know that our main cycle was moved to that interval. So, when you're drawing your picture, you need to take that into account. Okay, so let's see. First thing that we're going to do is we're going to place the location of this cycle, which is negative 3 pi over 4. So let's see, the length is pi over 2 as a period. So if we say, let's say that I declare that this is negative pi over 2 right here. Let's see, if I want pi over 2, right, we need to draw at least 2 sides, okay? So we have all the way up to negative pi over 4. So let's put it here, negative 3 pi over 4. And then, let's say here we have negative pi over 4. Okay. So then we do our 4 pieces here, here, here. So we have negative 5 pi over a, negative pi over 2, negative 3 pi over a. Then we're going to draw the others, but this is our main cycle. So once we have this, then the next thing that we're going to do is we're going to locate the midline, because after the midline, then we will know using the amplitude what's the highest and what's the lowest point. So what was the midline for us? It was the line y equals 1, right? So let's draw that. So let's say that this would be 1, Okay, I'm gonna put one here. So I'm just gonna draw it like this. And remember, this here stands for the midline. This is the midline. So next, we're gonna figure out what's the highest and lowest point of the graph, and you do this by using the amplitude. So remember, the amplitude here was 2. So what does that mean? It means that we're gonna go, the highest point would be 2 units above the midline, and the lowest point is gonna be 2 units below the midline. So we're gonna go all the way up to 3. So 2, 3. And then 2 units below the midline, so we're gonna go down to -1. So highest point is gonna be at 3, and lowest point is gonna be at -1. Okay, so our graph would be between -1 and 3. You guys okay with this? Do you understand this so far? This setup that I'm doing. All right, so once you have this set it up, then it's time to put the key points. So let's see, remember, what are we graphing? Are we graphing a sine or a cosine function? We are graphing a sine function, okay? So always think about the shape of the sine. How does the sine look like? It looks like this, right? So that means that we're gonna have one key point here in the middle, then up, middle, down, up. Those are your key points for sine. If it would have been cosine, it's different. Because remember, cosine looks like this. So the key points are up, middle, down, middle, up. Do you understand this? All right, so we're drawing a sine function, so I'm gonna follow those key points. So we start in the middle line, and then we move up, middle, down, and then middle. Okay, so then you need to ask yourself, are we flipping our picture? Because if we flip the picture, when you go up, you will need to go down instead of going up. You need to do the opposite. So are we flipping our picture? And that's given by, of course, the number that you have in front. Notice that the number is positive. Since A is positive, then the picture is not flipped. So let me write that here. Because A is positive, then the graph is not reflected. Okay? We don't have to reflect the graph, so there is no need to flip it. So that means that we're gonna keep on going the natural way, up and down and so on. So anyways, for the sine, we begin at the midline, and then we go up. Okay, one red. So we go up, then we go down to the middle, then we're gonna go down, and then we finish at the middle line. Okay, and now we can graph. So this would be go up, down to the middle, then go down here, and then back to the middle. So this is how the main cycle will look like. Do you understand this? Okay, so now let's draw one more cycle. Okay, because remember, we should always have at least 2 cycles. So this keeps on doing this to the left. Okay, now let us write one more to the right. So again, we start at -pi/4, and the length is going to be pi/2. So that will be pi/4 right here. And we just have to split into 4 equal pieces, and we nicely have them there. So we just keep on adding pi/a. So -pi/4 plus pi/a is -pi/a. Then we have 0. Then we have pi/a again, and then we have the pi/4 when you add an extra pi/a. And now we just keep on doing the same movement. So middle, then up, middle, then down, and then back to middle. And so we graph. and then just keeps on doing the same thing over and over towards the right and over towards the left. Okay, questions? Questions on this? So I strongly encourage you to, to do examples as soon as you can now, because you have these ideas fresh. If you let this go and then you come back tomorrow or after tomorrow, you might not remember what's happening here. Okay, so I encourage you to try several problems on your own before you do something else. That way you can get this ingrained in your brain. But anyways, let's see, when you see the word amplitude, because what's important is to understand these words. When you understand these words, then you should be able to come up with this picture. So do you understand what amplitude is? All right, a midline, is it clear in your head what the midline is of the graph? Okay, the period. Remember, period is the length of the main cycle, and then the phase shift is just the shifting of your picture. So that tells you where to begin your main cycle. All right. Once you have that, you draw this interval, this main cycle. Again, you don't have to. You can go straight to the picture, but it's easier to first do that in a little corner. So then when you go to the graph, you know exactly what is it that you need to put in the graph, and you don't have to be figuring these numbers out. So you should figure this out beforehand so you can do them the graph easier or quicker. Okay, so questions. We're gonna do another type of example now. I mean, I could repeat the same thing, but I feel like repeating the same thing is just we're gonna be wasting the time because I'm just gonna be repeating the same information. I would rather do a different type of example. Okay, in other words, how to do it backwards. And as you know, the homework likes to ask you questions like this. Okay, so of course you will have questions like given a function, then they will ask you for the amplitude, the period, graphic, etc. But then also, how about the other way around? If you are given a picture like this, how do you find the formula for it? So how do you provide a formula for it? Okay, so that's the kind of questions that I want to do now. And notice something that I want you to realize is that if I give you a graph, one of you may tell me that this is a sine function, but another one of you could tell me that this is a cosine function. Okay, because remember, sine and cosine, they are just a shift of each other. So what if instead of looking at this main cycle, what if someone said, well, I just want to look at this main cycle right here, or let me actually do the one that we have. What if someone wants to look at this as the main cycle? Because if you're given the picture, you're not being told what the main cycle is. And you could say, okay, I'm going to look at the main cycle to be from negative 5 pi over a to negative pi over a. And that has a cosine shape. So, and you can do that, and then you're going to get a cosine formula. Okay, but you need to understand that cosine and sine, they're just away from each other by a shift. So you can easily turn one into the other, okay, by adding or subtracting a pi over 2. So always keep that in mind. Okay. So that's one of the things that you need to be able to do. When you see a picture, you need to decide which one do you want to use. Do you want to use a sine formula or do you want to use a cosine formula if this is not given to you? So let me show you the example immediately so you see what I mean. All right. So this is the type of question I'm talking about. So here we're being asked to determine the formula. Now we're being told that this is a cosine function. So even if you want to think of this as a sine function, because you have all the right to do so, you can, for example, think of this point up to here, and then you can say, well, if you look at this looks like the sine function that was pulled to the right by some units, and then up, and some stuff happened to it. But technically you can think of it as being a sine function if you like. But here the problem is telling you to think of it as a cosine function. all right? So we don't have to make that decision. The one below, we will have to make that decision because it just says find a formula. All right, so our job is to find a formula for this function. And because it's telling us that this is a cosine function, then we already know that the way this is going to look is as follows. This is going to look like this. G of x equals a times cosine of bx minus c plus d. So really, the question is, what are a, b, c, and d? Do you understand this? Okay, so let's see. How do we do this? Once again, let's think about the same thing that we did originally, the way that we graph. Remember that one of the first things that we figured out was the midline, because the midline is important. So can you tell me what's the midline here for this graph? Can you tell me what's the midline in this graph? Very good, Maria, at 0.5, right? If you look at the graph, you should realize that at 0.5, we have the midline because the highest point of the graph happens at 1 and the lowest point of the graph happens at 0. So in the middle, we have 0.5. Everybody okay with this? So do you all see that this is the midline of the picture? All right, so now this already gives you information about something. What do we know about this? What would be d for the function? Remember, d is the one responsible for the midline, right? So what is d? It's 0.5. Very good. So I'm gonna write 1/2. Okay, we like fractions, so let's write fractions. Okay, so d is equal to 1/2. Okay, next, what else can we easily figure out from here without too much effort? Once we know the midline, the next thing that we can figure out is the amplitude of the function, right? So can you tell me what's the amplitude? So the amplitude is 0.5, very good. So remember, the amplitude is the distance between the midline and the highest point, or if you want, the midline and the lowest point, okay? So here, the amplitude, which is given by absolute value of A, right, is gonna be equal to 1/2. Now, our job is to figure out whether A itself is 1/2 or not. It could be negative 1/2. It depends what you decide your main cycle to be. Okay, and that's the next thing that we're gonna do. So now that we know the midline and we know the amplitude, let us try to figure out what's the phase shift, and let us try to figure out what is the period. Okay, all right, so let's see. First, we need to look at the picture and we need to choose a main cycle. And remember, we want to work with the cosine shape. So our cosine shape is like this, right? So it's shaped like this, or a shape like this, depending which one you want to pick. Okay. So that's the cosine shape. So now you can either pick here a cosine shape that will have a shift or a shape that doesn't have a shift. Okay. It doesn't matter which one you pick. I will recommend that if possible, pick it without shift because that's just gonna make the formula easier. Okay, we're not gonna have anything weird happening inside the x, if possible. So in this case, I want you to take a look at this. From 0 to 2 pi, and also because it's kind of clear that from 0 to 2 pi, we have this picture, and then that shape just keeps on repeating over and over again, right? So from 0 to 2 pi, then we have this shape, and then it just keeps on repeating to the right and keeps on repeating to the left. Do you all see this? So we're gonna declare that this will be our main cycle. Again, you can write a different formula. All right. So in fact, I'm going to show you an alternative formula that we could have written. But if possible, I would like to have a not shift. So this is actually what I'm going to do. So I'm going to declare that this is my main cycle, because we're not being told that. So you are free to choose whichever you want. So I'm going to declare that this is my main cycle. And because it's from 0 to 2 pi, then that means that we're not really shifting the cosine function anywhere. It's not being shifted to the right or to the left. Okay? So there is no shift of the original cosine function. So no shift. So that means that the phase shift is 0. Okay? And remember, the phase shift is given by c over b, and because this is equal to 0, then this tells me that the value of c above is actually 0. So we know that c is equal to 0, and with this now we can figure out what b is, because by looking at the main cycle we know that the length is 2 pi. So what's the period of this function? The period of this function is 2 pi, because that's the length of the main cycle, and the period is 2 pi over b. This has to be equal to 2 pi, so it follows then that b is 1, right? Questions about how we found c and b? Okay, perfect. Now the last thing that we need to decide is whether a is positive or negative. So because all we know is absolute value of a. So is it positive 1/2 or negative 1/2? Well, look at the main cycle that we pick. How does it look like? Does it look like the regular cosine or like the cosine that was flipped? Is it flipped or not? Look at the picture of the main cycle and compare to the usual cosine. It is flipped, right? Remember, the usual cosine is like this, and the main cycle that we picked was this one. And we picked it for convenience because it was from 0 to 2 pi. So that's why I picked that one, okay? When it's flipped, so I need to write negative 1/2, because the negative is the one that tells you that we are flipping, okay? All right, so now we have everything. So what's the formula for g? So g of x is going to be equal to negative 1/2 cosine of x plus 1/2. If you graph this function, you're going to get the picture that you see there. Questions? Questions on this example? So something that I want you to notice that's very important is that to be able to find all of this data, we needed to actually pick a cycle in which we know the beginning and the ending point, okay? And here we have several choices to do this, but sometimes we don't. So you always have to pick, whenever you decide what cycle you want to pick, you need to do it in such a way that you know where it begins and where it ends. Here we decided to pick the one that begins at 0 and ends at 2 pi, because we can see it from the picture. So this remark that I'm telling you is going to be applied now to this second example. Let's try to do this one. Now this one doesn't tell us whether this is a sine or a cosine function, and in fact it doesn't have to, because we could have done the previous problem using a sine function instead, okay? It's just that then the question is, if you wanted to use a sine function, then probably you will have to pick, let's say, from here to here as your main cycle, right? This, well, I did it there. From here to here, so it will be, you know, this shape, something like this. You can pick that as your main cycle, but then you need to know the beginning and the ending, and it's not clear what this is, right? The problem is not telling us what this is, so that's why using sine is not a good choice. But instead, cosine was good, because using the cosine shape, we could tell immediately what what those values were. Okay. Okay, so then let's go ahead and let's try to do this problem. Find a formula for this function. Our first job is to decide whether we're going to use a sine or a cosine. Let's see. I'm going to give you a minute to look at this and decide whether you want to use a sine or a cosine formula. And of course, then tell me why you're making such a decision. Remember, you need to know, you need to identify the main cycle, and this means that you need to know where it begins and where it finishes. Okay, does anybody has a choice? Should we use sine or should we use cosine for this particular problem? Sine, okay, very good. Why sine, Maria? Let's see, from where to where do you see the sine function? Because of the shape. Okay, interesting. To be honest, when I look at this, the first thing that comes to my mind is actually cosine because of this one, you know, this part right here. That's the first thing that comes to my mind. But you're right, we should use the sine here. And the reason why cosine is not a good choice is because, you see, if you want to use cosine, it begins here and finishes here. But then, you know, I mean, you could guess and say, oh, this looks to be the midpoint, so like 3.5, the x value, but we're not being told that. So you may want to go with the sure bet than with the guessing, right? So here, you know, it looks like that's 3.5, but we're not being told that. So we have to be careful there. What if it's not 3.5 and it's 3.51? So, you know, even at least, so that's why I'm asking you, why sine? It's true, there is also a sine shape here, but that one is a little bit more tricky to see. So, but that's the one to use. So why would you pick sine? From where to where? Tell me from where to where is your cycle, and that's the point. Once you make a decision, you need to know from where to where is your cycle to justify the sine shape.
From 1 to 6?
From 1 to 6. Okay, 1 to 6, what is that? So 1 to 6 would be from here to here. So that's this shape. That's not a sine, and that's not a cosine, right? But keep it going. Okay, it's hard to tell because, again, you need practice. How about this one? What if we go all the way up to 11? So start at 1. So remember, you have two choices. You have to be on the lookout for this shape or this shape. Okay, the red is the shape of a cosine, right? And then the green is the shape of a sine. That's why, like, you need to know the original one. We already see that cosine doesn't seem to be a good option because it's not really easy to see where to begin and where to finish the cycle. But for the sine, you could do the following. You can begin here at 1, and then notice that it finishes at 11 nicely, right? So you can do this. That's one part of it, but then you have to continue, right? This matches the shape of the sine nicely. And we know where it begins and where it finishes. Again, nothing wrong with choosing cosine, but then we don't know where it begins and where it finishes. So we should go with sine instead. Do you understand why we're making this choice? Notice that, for example, if you wanted to, you could also make the following choice. You could also pick from 6 to 16, and then it will be a flip sign. I'm just trying to tell you that there are different answers, okay? There are different ways to come up with equivalent answers. So, and then this will be a flip sign, what I'm doing here. You see, from 6 to 16, you could do that as well. And then that's just a sign that's flipped, okay? That's fine. That's what you get when you flip a sine function. Okay, anyways, but you know, if we can avoid flipping, we should probably do so because that makes our life easier. All right, so then let's work from 1 to 11, and then we're gonna work with the sine function. So right there. I wanted to do a lot of stuff today, but if I rush this, then you can get lost very easily. So it's better not to rush. Okay, so we made this decision. So that means that we're gonna look for a formula for this function, but we decided that we're gonna be using a sine shape. So this is what we are after. Something times sine times bx minus of sine of bx minus c plus d. Okay, and remember here b is positive. Now, because of the shape that we pick, what can you say about a? Is a positive or negative? So are we flipping the sign or not? Remember, the sign of A tells you where you need to flip the sign or not. We are not flipping the sign, so you immediately know that A is positive, since the graph is not reflected. So it's not being flipped. Do you understand this? Remember, this is important because once you know the amplitude, then you need to use the sign of A to figure out what the actual number is. Okay, so now let's begin. Let's see, midline. What's the midline for this graph? It's 4, so this immediately tells us what value does it give us from the unknowns. Remember, we're looking for A, B, C, and D. So what do we know? We know D, so D equals 4. Everybody okay with this? Can everybody see that the midline is 4? Yes or no? I mean, I'm asking a very simple question, guys. The reason why I'm asking is because only, you know, like the same names are answered in the questions in the chat. The 19 students connected, I just want to make sure that that the rest understand what's happening, okay? So midline, you literally look at the picture, the middle, that's the midline. And how do you figure out the middle? The highest point is 8, the lowest point is 0, right? Y equals 0. So what number is in the middle? That's 4. So that's your midline, 4. And as you know, D gives you that, okay? So D equals 4. Good. Next thing that we can easily do is figure out the period, right? What's the period of the function? Who can tell me what's the period of the function?
2 pi over b.
Okay, that's a formula, but for this function, what's the period? You need to tell me a number. What is the period? Remember what it means. What does it mean to talk about the period? That's the length of your cycle. So what's the length of the cycle? From where to where does the cycle go? That's the reason why we pick this one instead of the cosine, for example. Where does the cycle begins and where does it finish? Do you guys see the screen? I mean, you can answer the question very easily. Just look at it.
It starts at
Where
4
does it cycle?
ends at 11.
Okay, so what's the length of that? From 1 to 11, what's the length?
So 7.
Are you sure? From 1 to 11, what's the length?
Oh, from 1 to 11, 10.
It's 10, right? So the period is 10. Remember, guys, period is the length of the main cycle. The cycle begins here at 1 and goes all the way to 11. So what's the length of that? The length is 11 minus 1, which is 10. Do you understand this? Okay, so remember, that's why I asked earlier, do you guys know what these words mean? And that's what these problems are testing. Do you know what period is? Because, you know, all the information is there. We're doing barely any calculations. You're just looking at the picture and getting the information out of it. Okay, the period is 10. Now, as you said, this equals 2 pi over b. So we can now use this information to figure out b, right? Since the period is 10, and we know that this is equal to 2 pi over b, what is b? That would be 2 pi over 10 or pi over 5. So b equals pi over 5. Are we good with this? All right, so we know d, we know b. Now let's see, what's the amplitude? What is the amplitude? So the amplitude, which is absolute value of A, this is equal to 4, right? So that's the distance between midline and the highest point. But now we know that A is positive because there is no flipping. So this tells you then that A is equal to 4. So we know A, B, and D. We just need to figure out C. And so for that, we need to talk about phase shift. Is there any phase shift in this picture? Are we shifting the graph from its original position? Remember, the sine is always on the y-axis, so we move it, right? So we move it slightly to the right, 1 unit. Instead of beginning at x equals 0, the cycle is beginning at x equals 1. So phase shift, the phase shift is given by is equal to 1, right? Because that's the shifting that we did. This right here is the phase shift that we did, okay? And that's equal to 1, and you know the formula. This is C over B, so this means that C equals B, and B is pi over 5. So what's the formula for F? So F of x is going to be equal to 4 sine of pi over 5x minus pi over 5 plus 4. Questions?
What if we were starting at 2? What would the phase shift be?
2. I mean, it's wherever your cycle begins. The phase shift is always wherever your starting point of the cycle is. In this case, the cycle that we pick starts at 1, so that's our phase shift. If you started at 2, then the phase shift would be 2.
Oh, okay, thank you.
Yep. Remember, phase shift tells you this horizontal shift that you're doing, so it tells you the beginning of your cycle. So here C is pi over 5. Well, in this, that's if the shift were 2. Yes. If the shift were, it depends on B. Okay, it depends on B. If B was pi over 5, then it depends on B. Here, what we figured out is that the shift is equal to B. Because since the shift is 1, then C over B, C and B has to be equal to each other. So again, you first find the period, because when you have the cycle, you know the period. You use the period to get B. And once you have B, look at your cycle again, figure out where it begins, that's your phase shift, and then you can figure out C. Okay, but you need to know B first. Otherwise, you cannot do this. But B is obtained from the period. Okay, guys. So I'm gonna stop here. Just start practicing this with the homework, and next time I'm gonna do a couple more examples, and then we're gonna analyze tangent, cotangent, and so on. Okay, we're gonna do that on Tuesday. All right, have a good weekend, and I see you guys on Tuesday. I'm going to stop here. All right, so remember, try to do samples as soon as you can. That way you don't forget what we just did. Otherwise, this will be Chinese if you look at it 2 days from today.